PixInsight version 1.9 is out with their Multiscale Gradient Correction tool, which has been a long waited with their Mars project. So let's dive into it, check out the good and the bad. Welcome to SETI Astro. So with all core updates, you'll have to go to the PixInsight software distribution system in order to actually get version 1.9, so be sure you do that. And while you're there, also grab the XMars database files. You should also check out their official announcement where it talks about all the different tools and stuff that's in here. It does have the charts for what's covered by Mars currently, both in the northern and southern hemispheres. Image synchronization, which I think is a really awesome feature. You can link images together, so when you're scrolling on one, it scrolls on the other, zooming, all that fun stuff. You could also drag and drop astrometric solutions across, which is great. There's fast drizzling processes. They're redoing the astrometric solutions. Just a whole bunch of things that are definitely in here, and then just a bunch of behind the scenes stuff. So it definitely has some hardware requirements. So if your processor doesn't have AVX2 instruction sets in it, you're not going to be able to run version 1.9. But what I want to focus on today is looking at the multiscale gradient correction from their Mars project. This is the one I think everybody's been anticipating the most. If you don't know what their multiscale all-sky reference survey is, it's their project to completely image the entire night sky with a very short focal length telescope. I think they're actually using a 35 millimeter camera, and the purpose of that is that it can flow into a procedure created by Vincent Paris, who's part of the PixInsight team. It uses the local gradient in the short focal length image in order to correct the gradients in the long focal length image. What it attempts to do is match the two signals in the area, subtract the two signals, and then theoretically what you're left with is the gradient. And then you could just subtract the gradient. There's the whole workflow here that if you want to go about this manually, you can, but the multiscale gradient correction tool is the one that does this now all in PixInsight for us. And that process was something like this. You had your uncorrected image, your Mars reference image. You end up removing the small scale structures from the reference image and from the main image, and then you can actually get a gradient model, and then you can subtract it right when it's completely done. So let's kind of walk through the steps that you're gonna have to do in PixInsight for this, and then we can run through some examples, some where it works really well, and some where more traditional gradient removal is going to be more appropriate. The things you're going to need is an image solved image. So now under script, under astrometry is where you're going to find the image solver. You're going to have to ensure that it is solved. It still works with the old astrometric solutions. I don't know how long it's going to work with those. You may have to run image solver if it only had FITS data. For sure, they've completely revamped the astrometric solutions in the XISF files, so don't be surprised if you're going to have to just rerun image solver on some of your images. Once you have your image solved, you're going to have to run spectrophotometric flux calibration. You can define your sensor if you know what sensor you have, or use the ideal quantum efficiency, or load in a custom curve if you have an XML for it. There's an option for normal filters, red, green, and blue filters. So be sure you select your appropriate filters in here. There is also an option for narrowband filters. If you're using a narrowband filter mode, if you got like a mono image and you're doing H alpha, make sure you have your wavelength and bandwidth in there. If you're using one-shot color and maybe a dual band filter, make sure you have your filters all aligned and in there as well. So this is going to be a first step. You got to run this SPFC now. So we're going to go ahead and run that. When that is done, depending on how many stars you have here in your image and how well it aligned with the Gaia data, you're going to get some graphs here. What these do is it attempts to get the normalized scale factors between the red, green, and blue channels, or the gray channel if it's a mono image. The more stars you have in the image, the smoother this graph is going to look. And also, if the data is actually really tight, you may notice that the scale on the left-hand side gets really narrow. Like in the R case, it's 4, 4.1, 4.2. So there's actually not much spread in the data, even though it looks kind of chunky and spread out here. The data itself is not very spread out. So just something to look out for when you're looking through these graphs and what a good one should look like or not. Once you have ran SPFC, then you can actually open the Multiscale Gradient Correction tool. I'll set it on the defaults. You are going to have to add your Mars database files that you downloaded. You could add them right here, but those will disappear every time. So be sure you use a little wrench and actually define where you're getting these files from. So that way it'll save from session to session. And in this particular image here, it's just red, green, and blue. I have red, green, and blue. We're just going to have both these in there for the files. So if it does have multiple images of this particular area, it's going to be able to average those together to use as the reference frame. So be sure you load in both, and I'm just going to hit apply. And it does say it did find 2 images off in the console here. And when it's done, I did click show the gradient model, so we can go ahead and look at the gradient model. And just on the default settings, it actually looks pretty good. It's pretty nice and smooth. It has the darkened limb around there. I don't see much structure in there at all. There may be some little bit of brightness in there, but honestly, if you look at the values in comparison, 095, 192, and 184 to over here, 095, 192, and 184, there's absolutely almost no difference between these values. So STF is really just stretching it a lot to look at these. So that's a nice smooth model. And now we have our corrected image based on the Mars database reference images. So we can look at the before and the after. And then when you're in the linear state, be sure you always rerun your STF after gradient removal, because if the gradients were large and the STF was defined originally, it may look weird after the gradient's actually removed. So be sure you rerun STF. And so in this case, turned out really, really amazing for the multiscale gradient correction, and you know it is accurate to the sky. Here we're running it on another image. This image has lots and lots of stars. So now you can see these graphs are nice and smooth just because there's more data points. And again, these are the scale factors. It disregards the tails and only uses the good stars. So the flux calibration is done. We're going to go ahead and now just run multiscale gradient correction again on the defaults. And in this case, it says it has 4 images. It's actually integrating 4 of them. And here's our gradient. It looks like a perfectly nice, smooth gradient. Here's the before and the after. All right, now let's go look at some more complicated examples where we're going to have to mess with settings to try to get the best gradient correction as we can. And then we'll compare that to something just like ADBE, a more traditional gradient correction method, and see what comparisons we can derive from that. So this is going to be a harder example now. We have Andromeda here. It's a large structured object in the center. It does have quite a bit of a gradient running across it as well. So again, the first thing we have to do is run SPFC. Okay, SPFC is done. Again, just a plethora of stars here, so it's going to be able to generate some really smooth graphs and get the norms for the scales with SPFC done. Again, I'm just going to start on the default settings and we'll go from there. And with the default settings, you can see now that yeah, there's definitely some stuff that's not gradient that's coming across. There's a big chunk of Andromeda and its brightness that is going across, and you know, these aren't small values. from 0.042 down to 0.038 for that dark band there. So it is doing some over and under correcting for sure, considering this is linear data. Those are some fairly large numbers. So let's go ahead and look at some of the things we could do. The first thing to do is do your gradient scale. 2048 is probably going to work better for most people's images with modest sized amateur equipment. So focal lengths, 600 to 1200, you're probably going to want a gradient scale of that 2048. It's going to help more correctly match the size of your image to the pixel scale of the reference images in the Mars database. So this is the first thing to try, is just change that to 2048 and hit apply. Now we can see that in this case it is a much smoother gradient. There may be some overcorrecting in Andromeda, not a whole lot. So we can try to further improve a little bit here. There's the scale factors down here. You may have to adjust up or down depending on your image. It's going to take some trial and error to see even which way you need to go. I'm going to try going up. If you hit the control button or command on Mac, it'll move them all linked together for you. So I'm going to try like a 1.5 and just hit apply now. And you can see I think I went too far with it. So now it's almost like it went too dark. So 1.5 was too much. I'm going to try just a 1.2 next. And that's better still. So not quite as much overcorrecting with the Andromeda in the middle there. So 1.2 is probably the best for this particular image. And then you can go ahead and again, always just rerun STF. So there's our before with the green and the magenta cast. And now it's nice and flat. Let's do another one where traditional methods are probably going to be more beneficial than multiscale gradient correction. So here I have the monkey head and H alpha. First thing again is we need to run spectrophotometric flux calibration. Now this is narrowband. So I have the gray filter, H alpha's wavelength, my bandpass on my filter, and we're going to go ahead and run it. All right, here's the SPFC graph. Now this is really tight if you look at the scales there. So this is in very close alignment actually with the Gaia data. So cool. But now it's time to run Mars. So now running Mars on this, I'm going to have to change the gray filter to H alpha because it's an H alpha image and we got to make sure we're using the correct filter in the Mars database. And we'll just keep the defaults for now and hit go. If you do have a weird result, make sure your filters are correct for your image. So if this was just set at L, it's probably going to do a lot of overcorrecting or something. But let's go ahead and look. Oof. So right off the bat, it just way overcorrected in the middle of the monkey head. And you can see that here. These very dark areas now from the overcorrection. So we're going to have to adjust some settings here. Let's move the gradient scale up to the 2048 like we had talked about before and try again. Okay, the result is definitely smoother. It's still overcorrecting. It's still much too bright here in the center compared to the surrounding area, right? We got like a 0.0166 in the center. Here is 0.02. So quite a bit brighter that it's subtracting out. And you could see that in the middle, it took a lot of brightness out of the core itself. So the next thing to do is try adjusting the scale again. So I'll bring it up to like a 1.5 and we'll just, we'll give it a shot. That's better. It does have some correction in there. You almost see like a ringing around it. So the structure in the reference model is definitely not quite in alignment with the structure scale in our image. So the next thing to try is reduce the structure separation. So this is going to minimize the effect structure has on the gradient model itself. It's defaulted to a 3, but let's try a structure separation of 1. Okay, with a structure separation of 1, now that ringing is almost gone. It's just a little bit, 0.017 to 0.0175 in the center. So pretty darn good for the actual gradient correction. And here's the after and the before. It doesn't affect the center much at all. Maybe a slight amount here, right? It depends on how exacting you want to be with your gradient correction. We could try adjusting the sliders a little bit more, but I don't think you're going to get much better than this with multiscale gradient correction. So we're going to keep this off to the side. We'll go back 1, and now I'm just going to run my ADBE, and I'm going to make a exclusion area. I don't want any points down inside the monkey head itself. I'm going to do a poly degree 1 since it was kind of bright in the bottom and dark up in the upper right, so it kind of has that linear look to it. I'm going to just click execute for ADBE. And now here's the gradient ADBE found. It's a nice smooth gradient, bright in the lower left, dark in the lower right, just like the image looked like. And we can compare that to our image from the multiscale gradient correction, where there is some structure here where it was taking it out of the monkey head versus the nice linear gradient that ADBE produced. So in this particular case, ADBE, or just placing points in DBE, right, manually if you want to do that too, is going to be giving you the much better correction than multiscale gradient correction, at least as far as the gradient as it's presented in the image. Let's hop into one more narrowband one. This is Eagle with a very bright core, nebulosity completely throughout the image. So again, first thing to do is SPFC is done running. Now it's time to open up Mars. And again, we have an H alpha filter. It's always important to check that. And we're going to go ahead and run it. And as expected, it overcorrected in the core there. In fact, it overcorrected really bad. You could see just how bad it is. Here's the before and the after. So we're definitely going to have to mess around with some of the settings again. First thing always to try, set the gradient scale higher to 2048. We'll give that a go. Much better with the brightness level at least being smooth, but it's still quite overcorrecting in the center. We got 0.01, almost 6 versus 0.013. So for linear data, that is still quite a bit of difference, and it's very apparent here. Here's the after and the before. And the after, I mean the darks just got way too dark. So then again, the next thing to try doing is let's go ahead and drop this structure separation down to 1 and try again. All right, that definitely helped. It's a much smoother. Still looks like it's overcorrecting in the center, and you can definitely tell that it is. Here's the before and the after, especially around these dark areas here where it is doing overcorrecting. So then let's go ahead and try adjusting the scale factor. We'll try the 1.5. We'll keep everything else where it is. That is getting better still. There's still structure in the center that we know isn't gradient sitting there. So let's go all the way up to a 2 now, and we'll give it another shot. I think we're almost getting there. Here's the before and after. It does look like it's just pulling brightness out of the core itself. I mean, I might try going all the way up to a 3. And now we are getting to the point where we're almost seeing some dark ringing in here. So this is probably all the multiscale gradient correction tool is going to be able to provide as far as correcting. And we can see a brightness to a darkness as well. So we'll just kind of keep this one off to the side. And here's the before and after. Really almost no change. Maybe a little overcorrecting up in this area. But let's just go ahead and try ADBE. And we know there's some dark nebula up in this area there. and I'm going to just keep it on a poly degree 1 and just click execute. So running it like that, here is the model that ADBE had, and we can see the before and after. Definitely no change in the core, and it evened out the upper corner there. And then again, we can compare that to the one that Multiscale Gradient Correction did. You know, at this point, because Multiscale Gradient is using a real reference, it's definitely going to be more accurate on the outer boundaries here versus ADBE here. So, you know, that's something to consider when you're looking at gradients and stuff like that too. So let's actually try a correction of 4. Yeah, and I think we're hitting the sweet spot somewhere between a scale factor of 3 or 4 for the eagle here. So here's the before and after. It almost looks like it moves some of the brightness from the right over to the left. So what are we going to take away as a summary? Amazing they got the Mars tool out. I think this is something everybody has been waiting for. It references real data. So if the patch of sky you're trying to correct has reference data, you can do it. This is not a one button push situation most of the time. It seems like you are going to have to mess with the gradient scale, the scale factors, and possibly the structure separation. Is it the scientifically accurate gradient correction I was hoping it was going to be? No. And the reason is all these parameters you have to manipulate, and then using your eye trying to tweak it to what you're expecting the gradient still to look like. So this whole time, right, we've been trying to minimize the bulge in the eagle there or in the monkey head, trying to tweak these values to what we are expecting the gradient to be. And that's in line with what they had in the video as well from PixInsight, that you will be adjusting these until you find kind of those sweet spot parameters. Your eyeball's not really good at knowing what's true and what's not. So there's still a little bit of ambiguity, I think, in gradient correction. Is this a big step forward? Yes. Do I think it's going to get better as they get more reference data and this is the only first release of the Mars data? Again, yes. So don't expect this to be the end-all be-all solution right now. You still may have to do traditional gradient removal, especially if it's not in the reference field. But even if it is, as we saw in the monkey head, you're just going to want to use traditional gradient removal. And even in the eagle here, depending on your data, you may be more apt to use the traditional gradient removal as well. It still may be overcorrecting in some of these other areas and undercorrecting in some as well. So that's the takeaway. Big step forward in trying to make gradient correction more accurate and more on scientific footing. It's not there in the initial release yet. You're still eyeballing a lot of stuff here. That's okay. As somebody that's put out a lot of initial releases, I know it changes, and it's going to change a bunch. So congratulations to the PixInsight team. I know this was a ton of work going into this, and I know there's going to be continued improvements and as the whole database is built up. So I guess this is probably the first video in a review of lots of different things as we continue on with their updates and progress. I hope this helps some people actually use multiscale gradient and how to adjust these sliders and everything as well, and kind of when to know if maybe just running DBE or Graxpert is probably the best bet. And especially something like I demonstrated with the monkey head, where absolutely just use traditional gradient removals in those kind of cases. Please comment, like, and subscribe.